Have you ever wondered how your device communicates over the internet? It all starts with an IP address. You see, every device that connects to the internet has a unique identifier, known as an Internet Protocol or IP address. These addresses are like the phone numbers of the internet, helping to route information to the right places. Now, there are two types of IP addresses that you should know about: public and private. Public IP addresses are unique throughout the entire internet, kind of like your home address. They are what your device uses to communicate with the world. On the other hand, private IP addresses, though they may not be unique globally, are unique within their own local network, much like the room numbers in a hotel. They're used for local communications within a private network. So, to dig deeper, let's start with understanding what public IP addresses are. Public IP addresses are unique identifiers used by your devices to communicate over the internet. They're like the digital equivalent of your home street address, allowing data to be sent and received from specific locations in the vast world of the internet. Now, public IP addresses aren't just random numbers. They are assigned by a global organization known as the Internet Assigned Numbers Authority, or IANA for short. IANA ensures each public IP address is unique, preventing any confusion or overlap in the digital environment. One of the key characteristics of public IP addresses is their routability on the global internet. What does that mean? Well, just like a letter can be sent from New York to Tokyo because the postal system recognizes both addresses, data packets can be sent from one device to another across the globe, thanks to the globally routable nature of public IP addresses. Public IP addresses can come from a variety of ranges. For instance, Class A addresses range from 1.0.0.0 to 126.255.255.255. Class B addresses range from 128.0.0.0 to 191.255.255.255, and Class C addresses range from 192.0.0.0 to 223.255.255.255. So, to sum it all up, public IP addresses are unique identifiers assigned by the IANA. They enable our devices to send and receive data across the global internet thanks to their routability, and they come from specific ranges, which help classify them into different categories. Now that you know what public IP addresses are, let's move on to private IP addresses. Similar to public IP addresses, private IP addresses are unique identifiers used by devices, but there's a twist. You see, private IP addresses are reserved for use within private networks, and unlike public IP addresses, they are not routable on the global internet. This means that they cannot be used to identify devices on the internet at large. The reason behind this is quite simple. Private IP addresses are designed to enable multiple devices within a local network to communicate with each other without requiring a unique public IP address for each device. This not only conserves the limited number of available public IP addresses, but also adds an extra layer of security, as devices on a private network are not directly exposed to the internet. Now let's talk about the ranges of these private IP addresses. They are specified in a document known as RFC 1918. Depending on the size of your network, you might be dealing with different classes of IP addresses. For instance, Class A private IP addresses range from 10.0.0.0 to 10.255.255.255. This is a large block of addresses suitable for large networks. Class B private IP addresses range from 172.16.0.0 to 172.31.255.255. This range is suitable for medium-sized networks. Finally, Class C private IP addresses range from 192.168.0.0 to 192.168.255.255. This range is typically used for small networks. So, we've covered private IP addresses, but how do these private network devices communicate with the global internet? Let's find out. Imagine a scenario where a device in a private network wants to connect to the internet. This is where Network Address Translation, or NAT, comes into play. Picture NAT as a kind of translator or an interpreter, smoothing out the communication between your private network and the wide open world of the internet. It's like a linguistic expert who's fluent in both public IP and private IP, facilitating a smooth conversation between the two. Let's dive deeper into how NAT works. Suppose you have a device within your private network, like your personal computer. This device carries a private IP address, a secret code that's only recognized within the confines of your private network. But what happens when this device wants to reach out to the internet, which operates on public IP addresses? Here's where our translator, the NAT, steps in. It takes the private IP address of your device and translates it into a public IP address that the internet understands. This way, your device can send and receive data over the internet, all while keeping its private IP address undercover. But the magic of NAT doesn't stop there. When the data returns from the internet, the NAT takes the public IP address and translates it back into the private IP address of your device. This ensures the data finds its way back to the correct device in your network, like a homing pigeon returning to its loft. What's more, NAT can handle multiple devices within your private network, each with its private IP address. It assigns a unique port number to each device's internet connection, allowing it to distinguish between them. It's like a switchboard operator, connecting multiple internal phone lines to the outside world. So NAT acts as a bridge connecting your private network with the global internet, using public and private IP addresses. It's an integral part of the communication process, ensuring that your devices can reach out to the internet and that the internet can find its way back to your devices. Isn't it fascinating how these complex processes happen behind the scenes, making our online experiences seamless and straightforward? So the next time you browse the internet, spare a thought for the humble NAT, working tirelessly to keep your devices connected. So, NAT acts as a bridge connecting your private network with the global internet, using public and private IP addresses. Hopefully, you have a better understanding of public and private IP addresses now. Let's take a moment to recap what we've learned and tie it all together. IP addresses are like the postal addresses of the internet. They help to identify devices and route traffic correctly. But not all IP addresses are created equal. They are divided into public and private categories, each with its own unique characteristics and uses. Public IP addresses are the unique identifiers of devices on the global internet. Think of them as the street addresses of cyberspace. They are assigned by the Internet Assigned Numbers Authority, or IANA, to organizations or internet service providers. These are the addresses that allow us to connect and communicate across the vastness of the internet. Public IP addresses can be assigned from various ranges, but some common ones include Class A, ranging from 1.0.0.0 to 126.255.255.255, Class B, which spans from 128.0.0.0 to 191.255.255.255, and Class C, that covers 192.0.0.0 to 223.255.255.255. On the other hand, we have private IP addresses. These are reserved for use within private networks and are not routable on the global internet. In other words, they're like the room numbers in a large building. They make sense within the building but don't mean much outside of it. Private IP addresses are defined in RFC 1918 and enable multiple devices within a local network to communicate with each other without requiring a unique public IP address for each device. These ranges include Class A from 10.0.0.0 to 10.255.255.255, Class B from 172.16.0.0 to 172.31.255.255, and Class C from 192.168.0.0 to 192.168.255.255. When devices in a private network need to access the internet, a network address translation, or NAT device, is typically used to translate between private and public IP addresses. So, in summary, public IP addresses are used for identification and communication on the global internet, while private IP addresses are used for communication within a private network and are not routable on the global internet. Remember, these are general guidelines, and specific allocations and use cases can certainly vary. Always refer to the latest standards and documentation for the most accurate and up-to-date information. Remember, understanding IP addresses is fundamental to managing and troubleshooting network issues. So, keep exploring and stay curious.